RC beam as per IS 456 2000. As per clause number 23, how to calculate effective depth? Effective depth of the beam is a distance between the center of the area of tension reinforcement and the maximum compression fiber, excluding the thickness of finishing material not placed monolithically, width of the member and the thickness of any concrete provided allowed for wear. This will not apply to the deep beams. Okay, so I will explain you. In this diagram, you can see here is one cross section of singly reinforced beam. Capital D is suggested as total D, small d is an effective depth, B as in effective width. Okay, and here it is given as effective cover and clear cover. So eventually your calculation of effective depth will be the total depth minus effective cover, or if you given with clear cover, then effective depth is equal to the total depth minus clear cover minus diameter of bar which we have provided in the tension reinforcement divided by 2. Why? Because as you can see in the in the definition, that the effective depth of the beam is a distance between the centroid of the area of tension reinforcement. Okay, so let's say here is something the centroid of the tension area reinforcement to the top compression fiber. So this complete distance will be considered as the effective depth. Now, as per clause number 22.2, how to calculate effective span of the beam or slab. The case number 1 is a simply supported beam or slab. So, what is the procedure to determine effective span for simply supported beam or a slab? Let's read first. The effective span of a member that is not built integrally with its supports shall be taken as clear span plus the effective depth of the slab or a beam or center to center of the support, whichever is less. Okay, so I'll explain you. Effective span of a simply supported beam or a slab will be 1 as clear span plus effective depth divided by 2 plus effective depth divided by 2, or center to center distance between the support, whichever is less. First you have to calculate both of the value 1 and 2, and eventually whichever value is less, and that will be the effective span of your beam or slab. As you can see in the diagram, here is a slab or beam, simply supported beam or slab, which is resting on if it is slab, which it will be resting on the beams, and if they are beams, they are resting on the walls or maybe on the columns. Okay, so you can see the distance between two supports is considered as a clear length, and center to center distance between the support is considered as the effective length. Okay, so eventually the effective span, or we can say the effective length of particular beam or slab is a clear span plus effective depth divided by 2 plus effective depth divided by 2, or the center to center support. Okay, so how to calculate center to center distance is clear span plus support, it means width of support divided by 2 plus width of support divided by 2. Now for continuous beam or slab, as per the IS 456, let me read first. In the case of continuous beam or a slab, if the width of the support is less than 1/12 of the clear span, the effective span shall be in 12.2, as in case number 1. Okay, so let's understand this first. Okay, so here is a width of support which is less than 1/12 of the clear span. Okay, so as you can see, here is a continuous slab or a continuous beam. These are the clear span between the supports, and BS is a width of the support. Okay, so if my support is less than 1/12 of the clear span, then the effective span will be the clear span plus effective depth divided by 2 plus effective depth divided by 2, or the center to center distance between the support. First we have to calculate this, and then whichever is less you can continue with the effective span. Now let's go further. If the support are wider than 1/12 of the clear span or a 600 mm, whichever is less, the effective span shall be taken as under. It means we have to continue with other three cases, or we can say the other three condition if our supports are wider than 1/12 of the clear span or 600, whichever is less. So the first condition is for the end span with one end fixed and other continue, or the intermediate span, the effective span shall be taken as clear span between the support. Okay, so I'll explain you. If the width of support is more than 1/12 of the clear span, then we have total two conditions here. One is end span with a fixed support and the end span with a free support, and the another will be the continuous one. Then you can see in this diagram I have one slab or a beam having the fixed end and the another end is continuous. Okay, this is the clear span. Okay, and BS will be the width of the support, then effective span will be the clear span. Now for the next condition, if the end span with one end free and other is continuous, you can see this diagram I'm showing here. Here is a beam or a slab which is supported with supports having the width BS. Okay, and the effective span will be the clear span plus effective depth divided by 2. Second, clear span plus width of the support divided by 2. First we have to calculate this both condition and take effective span whichever is less. Now for cantilever slab or a cantilever beam, the effective length of the cantilever beam or slab will be taken as its length to the face of a support plus the half of the effective depth, except where it forms the end of the continuous beam, where length of center of support shall be taken. So you can see here is one cantilever beam or cantilever slab with a width of support BS. Okay, then the effective span of this particular beam or a slab will be clear span plus effective depth divided by 2. Now to check control of deflection for the simply supported cantilever or the continuous beams or slabs, read the clause number 23.2 in IS456 2000. Let's read the clause. For the vertical deflection limits are generally be assumed to be satisfied provided that the span to depth ratio not greater than the values obtained as below. The basic values of span to depth ratios for the span up to 10 meter. It means if our beam or slab has a span length less than or equal to 10 meter, we have to take our span by depth ratio, or we can say span by effective depth ratio. For cantilever beam or slab it will be 7, for simply supported it will be 20, and for the continuous beam or slab it will be 26. Now for the span of beam or slab more than 10 meter, for cantilever beam or slab, the span by depth ratio will be equal to 7 only. It is similar as previous one. For simply supported beam or slab, span by effective depth ratio will be 20 multiplied by 10 divided by span of the element, In third condition, for the continuous beam or slab, the span by effective depth ratio is 26 multiplied by 10 divided by span.